For the benefit of the recording, this is the dissolved oxygen and temperature training for the 2025 Cooperative Lakes Monitoring Program. My name is Tamara Lipsey, and I'm an aquatic biology specialist with the Water Resources Division at the Michigan Department of Environment, Great Lakes, and Energy. I've been with EGLE for 22 years, and I've been with the MiCorps program for this will be my fifth year. At EGLE, I am an assessment biologist, so I do a lot of water quality assessment in both lakes, streams, and rivers. These images show some electrofishing I've done. I do aquatic insect surveys. I have done snorkeling for invasive plants. And up in the left is me doing Secchi discs. So I have the pleasure of talking about dissolved oxygen and temperature monitoring. So first, I wanted to put out a poll to see what the diversity of experiences are for the people here in the audience. So let me know how comfortable you are with dissolved oxygen and temperature monitoring. Let me know if you're not entirely sure why it's important and it's brand new to you. If you have signed up to sample it for the first time this year and are here to learn. If you'd sampled it before, but you're here for a refresher. And if you've done it for many years, but you are here because you can always learn more. So I'll give you a few minutes to just fill out that, and then we'll see what the results look like.
The answers are coming in. Looks like about half of folks have typed in their answer, so we'll give folks a few more seconds to put their answers in. And then we'll share the results. All right, looks like we've got a critical mass,
All
so
right, thank you.
there's our results.
Okay, so it looks like we have a decent amount of new people. So you're either not entirely sure why it's important and you're here to learn, so that's great. This is an advanced parameter. So if you're new to the program, you can sign up for this parameter after you've been enrolled in the program for a year. Looks like quite a few of you are signed up to sample it for the first time this year. So thank you very much for joining. And then some of you have sampled it before, but are here for a refresher, and there's a few veterans in the group as well. There we go. Took a second. So this is just an overview of how this training is going to go today. First, we're going to talk about why dissolved oxygen and temperature are important. And then we're going to go over how the MiCorps program, dissolved oxygen and temperature program works. We'll spend quite a bit of time on the equipment and what it looks like and how to use it will be next with the procedure. And then we'll talk about some important steps for the end of the year. So just real quick, this is how dissolved oxygen and temperature are measured in the Cooperative Lakes Monitoring Program. We have these meters that have a cable that then go into the water at different depths, and the meter takes measurements, and then you record those measurements on data sheets. What is dissolved oxygen and temperature? Temperature is pretty simple. It's just how warm or cold the water is, and a lot of chemical processes depend on temperature. And dissolved oxygen is just what it sounds like. It's the amount of oxygen dissolved in the water, and then it's available for aquatic organisms like fish and aquatic insects to use. Temperature and oxygen is important because it impacts the biological community, like I said, with having oxygen for fish and other insects to live, but it also has impacts on physical um, characteristics of a lake and the chemical characteristics of a lake. And we're going to be learning about that. We're going to start with temperature. In your lake, you've likely noticed when you jump in to swim that as you swim deeper, it gets colder while the water on top is warm, so you try to float on top to stay in the warm water. And this is because water gets warmer because of the sun at the top of the water. And when water gets warm, it becomes lighter or less dense and it floats on the top. Colder water is more dense and so it sinks. And this is called thermal stratification. So by measuring temperature, you can determine how your lake stratifies. And this is a diagram of the common temperature profile of a lake in the summer months in Michigan. The upper layer is called the epilimnion, and that includes what we call the littoral zone, which is that area closer to shore that's shallow enough that the sun can reach the bottom and then plants can grow. The next zone is called the metalimnion, and it includes an area that we call the thermocline, which is where there's a pretty sudden decrease in temperature. And this layer is usually a fairly thin layer. And then the bottom zone is called the hypolimnion, and it's the coldest layer. So by measuring temperature, you can define where your thermal layers are in your lake. So now we're going to talk about how temperature changes throughout our seasons. So we'll start with summer in the upper left-hand corner where we just talked about where you have an epilimnion, a metalimnion with that thermocline, and then a hypolimnion. And then what happens in the fall as the air temperature starts to drop and that sun gets lower in the horizon, the water temperature drops. And then there's usually more wind in the fall, and it also cools the surface of the water. And then as that water cools, because it gets more dense, it starts to sink. And then the water that was below, which previously might have been colder, is now warmer, and it gets pushed to the top because it's lighter. And this process is called lake turnover. So then as we get into winter, which is in the bottom right, the water keeps cooling at the top and keeps mixing until the water reaches less than 4 degrees Celsius, which is also 39.2 degrees Fahrenheit. And at that point, water has this funny property that it's lighter when it's warm, but after it gets colder than 4 degrees Celsius, it also gets light. And so that's why we have ice on top of all of our lakes in the winter. And it's really important because the water underneath, although it's cold, it's warm enough that it allows fish and other organisms to survive. And then in the spring, the ice melts, and as it melts, it gets more dense and falls to the bottom. And then the water at the bottom again gets pushed to the top. And nutrients and oxygen from the bottom are again mixed throughout the water column until everything is the same temperature. And then as spring goes on, the surface of the water will start to warm up, and then you will get that stratification again. Oh, there we go. Okay, next we're going to, oh, I'm going to pause that real quick. Next, we're going to watch a video on dissolved oxygen. So we're moving on from temperature to dissolved oxygen. And to just give you a break from my voice, we're going to watch a video that I think does a great job of explaining dissolved oxygen and how it changes in lakes.
Tamara, I'm afraid your volume isn't coming through. You may want to
Uh-oh.
pause and check
Yep.
your sharing.
Yep. Oh, shoot. Just won't let me get to the stop sharing. There we go. Again, so I don't want to leave the meeting. Sorry about this, everybody.
While Tamara works on that, we had it working this
Mm.
morning, so it'll just be a quick change. When you're in the share window, you should have the
Yeah, I just can't get to the share window.
share. Well, I would suggest maybe stop sharing entirely because we can still see your desktop.
Yeah, that's the part I can't get to.
Let me see if I can control that for you. There we go. That should have stopped
Thank
it.
you so much.
You're welcome.
Okay, let's try this again. Now I'm gonna have to open my PowerPoint because I was clicking everything. Mm, mm. Luckily, when I did this in person, there was extra time at the end. So we'll be okay. Share. Click the little share sound button. We're almost there. All right.
Your slides look good, so now we just need to check to see if that audio worked.
Sound good?
Success. Good job. Thank you.
Yep.
Imagine a world where we weren't surrounded by air. Without the oxygen in the air that we breathe, we wouldn't survive very long. But what about animals underwater? They need oxygen too.
Sorry about that.
Where do they get it? The answer is from the water, because water actually also contains dissolved oxygen. Dissolved oxygen is just what it sounds like. It's oxygen that's dissolved in water. But what does it mean for something to dissolve? If you've ever mixed sugar and water, you've noticed that the sugar seems to disappear. But what really happens is that the molecules of water mix with and surround the sugar molecules, breaking up the large sugar granules to make a sugar-water mixture. More specifically, since the parts of the mixture are spread out equally and evenly everywhere, we can call this mixture a solution. So when we say that something dissolves, it just means that it goes into an evenly distributed mixture called a solution. Now, like those sugar molecules, oxygen molecules also mix evenly with water molecules to form a solution. In other words, oxygen dissolves in water. But how does the oxygen get there in the first place? Well, there are two main ways that oxygen can enter a body of water, like the ocean or a lake. One way is from the atmosphere, or the air around us. Oxygen makes up about a fifth of the atmosphere, and these oxygen molecules are constantly bumping into and entering water. Even more oxygen enters water through photosynthesis. You probably know photosynthesis mainly as the way that plants around us feed themselves. But there's actually a whole slew of other photosynthetic living things aside from plants. From tiny green bacteria called cyanobacteria to little phytoplankton with crazy names like dinoflagellate and even crazier bodies. All these creatures can produce food through photosynthesis. But in doing so, they actually also produce oxygen, which then dissolves in the water. What happens to this dissolved oxygen? Remember that like us other living things, The animals, plants, phytoplankton, and bacteria living underwater also take up oxygen to live. Furthermore, oxygen molecules are continually shuttling back and forth between the atmosphere and the water. But note that there's always at least some amount of oxygen that stays dissolved, and this amount depends on water conditions like the saltiness and temperature of water and how much dissolved oxygen there is compared to the oxygen levels in the air. Now, why does the amount of oxygen already dissolved in the water and the surrounding air matter? Well, it's the same principle as walking into a crowded room from an empty hallway. You don't want to go in, and the people inside are trying to get out. In the same way, if there's more oxygen in the water than in the surrounding air, then the oxygen moves to the roomier atmosphere. Or if there's more oxygen in the air, then the oxygen moves to the water. The principle is the same for the saltiness of water. If you've ever tasted seawater, you know how salty it is, and that's because there's salt dissolved in seawater. Well, those salts are also taking up space in the water. You can imagine that as adding even more people to your crowded room, and the more people there are, the less room there is for you. So the saltier it is, the less space there is for dissolved oxygen. What about temperature? Well, when things heat up, they start moving around. Imagine yourself in a crowded room again. As everyone starts jostling around, it's a lot easier to move out of the room. Again, it's the same for dissolved oxygen. The oxygen molecules warm up and they start vibrating, making it easier for them to escape the water. So let's sum that up. Dissolved oxygen enters water from the atmosphere and from photosynthesis, and then gets taken up by living things or exits into the atmosphere depending on water temperature, saltiness, and the amount of already dissolved oxygen. Now you're probably thinking, who cares what the amount of dissolved oxygen is? Well, remember that living things need oxygen to live, and the more oxygen there is, the more animals can live there. So scientists measure dissolved oxygen to find out how healthy a body of water like a lake or a river is. But animals also adapt to the amount of dissolved oxygen. Fish like salmon need a lot of oxygen so they can only live in colder places, but fish like catfish can live in warmer waters because they need less oxygen. If you've ever wondered why the kinds of fish are different in different places, this is one reason why. Unfortunately, even these fish die off at very low oxygen levels, and humans have been decreasing freshwater oxygen levels in a process called eutrophication. Eutrophication is a big word that just means adding a lot of nutrients good for growing, like nitrogen and phosphorus, to a lake or a river, usually by pollution. That causes a lot of plants and cyanobacteria to bloom. Aren't plants good though? Don't they produce dissolved oxygen? Well, yes, but when they die, they sink to the bottom of the lake and decay there, and this decay uses up all the oxygen in the lake. With no oxygen to breathe, the fish and other animals die and the lake becomes unhealthy. So throw your trash properly and recycle. Together we can preserve our marine and freshwater ecosystems.
Okay, so I really like that video, except for the end, because although recycling is great, it does not help with eutrophication necessarily. However, the video makes a lot of good points, and we will review those take-home points. So first, the amount of salt and the temperature of the water both impact the amount of dissolved oxygen in the water. Oxygen enters the water through the air or by photosynthesis from plants and algae. Too much algae or cyanobacteria leads to low dissolved oxygen because when they die, it uses up oxygen. Nutrients speed up the growth of plants and algae and the eutrophication process. And the overall take home is that understanding dissolved oxygen levels in your lake is one more tool to understanding the health of your lake. So here is an example of what a graph of dissolved oxygen and temperature looks like after you take the measurements with the meter. So I'm going to spend some time. So first we'll just talk about the graph itself. On the bottom of the chart is the amount of dissolved oxygen, which is shown with circles, or the temperature, which is shown in triangles. And temperature is in degrees Celsius, and dissolved oxygen is in milligrams per liter. And then along the other axis, we have depth. So we go from 0 feet where you're up here fishing or boating or swimming, and then down to this particular lake, looks like it was around 65 feet deep. So you can see that with the dissolved oxygen that it's right around 9 milligrams per liter up until about 20 feet, where then it starts to decrease. And then until we get to about 32 feet, where the number is less than 1 milligram per liter, which at this number, it would not support any fish. Most fish need, warm water fish species need around 4 or 5 milligrams per liter, so they could live shallower than 30 feet. And then if there's cold water fish, they need as much as 8 milligrams per liter of oxygen. So they would be living 25 feet or less. For temperature, we can see that it starts around 20 degrees Celsius, which my notes say that's 68 degrees Fahrenheit, and it stays that temperature until we get to about 20 feet. And then all of a sudden, the temperature starts dropping pretty rapidly, and this is what we call the thermocline. And then eventually, it evens out at about 50 feet or so. So with this information, we can see where the epilimnion is, where that metalimnion or that thermocline is, and then where that hypolimnion is. And this was for Dead Spider Lake in Lake County in September. So as was mentioned in the video, a loss of oxygen can lead to a loss of habitat for fish, especially cool water fish, but also warm water fish if it's depleted enough. They both require lots of oxygen, and you can see as a stratification progresses over middle summer, that area where fish can live gets smaller and even smaller in late summer. And if you have a lake that's really progressed in eutrophication, there might not be any dissolved oxygen at the bottom of the lake. And even though it might be cold enough, it won't have enough oxygen. So I want to talk about one thing that you might see if you're measuring dissolved oxygen and temperature. And it seems a little different than the graph that I just went over. So we'll start with temperature. As you can see, it's staying pretty stable, and then all of a sudden we get that thermocline, and then it keeps decreasing all the way to the bottom. This is Gull Lake, which they can measure down to 100 feet. But the dissolved oxygen, it starts, around 8 or 9, which is what we would probably expect. But then at 30 feet, where that thermocline starts, there's a huge jump in the dissolved oxygen. It gets all the way up to probably 13 or 14 before it starts decreasing. But even at the bottom, it has at least 5 milligrams per liter of oxygen. And so this would be a lake that could have cold water fish. But what's happening here is a couple of things. One, the temperature is dropping. So as the video noted, as the water gets colder, it can hold more dissolved oxygen. But what also is likely happening is that some algae like specific depths, they like specific temperature, they like just the right amount of light. And at those depths, they will be producing like crazy and producing more oxygen. And so that is another thing that could be causing that bump in dissolved oxygen. So I want to explain quickly an interaction that temperature and dissolved oxygen have with nutrients. Here we have an oligotrophic lake in the summer in Michigan, we can see that it's warm at the top with the red and cool at the bottom with the blue. And there's lots of oxygen throughout the water column. Because it's oligotrophic, it has low amounts of nutrients, low amounts of plants and algae, and this helps dissolved oxygen stay present in the bottom of the lake. And in the presence of oxygen, um, phosphorus can stay bound in the sediments because phosphorus and iron bind together. However, here we have a eutrophic lake in the summer in Michigan, and we can see that it's warm at the top and cool at the bottom. Because it's eutrophic, it has high amounts of nutrients, high amounts of plants and algae, and low amounts of dissolved oxygen on the bottom due to the dying plants. And just a reminder, that's because as bacteria decompose the dead plant matter, um, it uses up the dissolved oxygen. And so when the dissolved oxygen reaches zero, the phosphorus that was bound to the iron is released from the sediment into the water column, where it then can be used again by the plants and algae that are there. So it's just a continuous cycle. Okay, one quick thing about dissolved oxygen and temperature and how we use it here at EGLE. We have in the state of Michigan a water quality standard or a law that says that in stratified lakes that there should be a level of dissolved oxygen of 7.0 in the upper third of the metalimnion. So this is this yellowish area right underneath the epilimnion. And we use that in lakes where we expect there to be cold water fish based on how deep the lake is and just its natural temperature profile. And we use this water quality standard to determine if a water body is meeting standards or not. So using the CLMP data alone, we listed 23 lakes in our 2024 integrated report, which is part of the Clean Water Act that we have to report to EPA and the nation. So it's really great data for us to be able to report on water quality. And if a lake is not supporting a cold water fishery, it helps with fish management decisions. And it also helps with making decisions about what actions might need to occur in that watershed to bring it back to designated uses. Okay, so that's all of the technical science background for dissolved oxygen and temperature. I'll take a minute and see if there's any questions that we can answer.
There are no questions, Tamara, that have come in the chat during
Okay,
the first part of your presentation.
okay. I'll give it a couple seconds and see if
Oh,
anybody
we
puts
just
in.
got one. Thanks,
Yep.
Marcia. Her question is, does any of the results from this testing affect our property values?
No, because I don't own property on a lake, but I would assume no. I mean, I think the dissolved oxygen and temperature just helps people know what type of lake it is, how it, if you're, I think, um, if you're a angler on your lake, I know some people who have their own meters, they like to use this to go figure out where they're going to go fishing for the year. But I don't know if it would affect property values, but I think most important, it just gives you information about your lake so that you know how to manage your property to help your lake.
Right. I think that's the only question for now, Tamara. So
Okay. Mm. Okay, so we're going to pivot a little and talk about how the dissolved oxygen and temperature program works with the Cooperative Lakes Monitoring Program. So you can either borrow a meter or you can purchase your own meter. Borrowing a meter is $60 and you'll get it at the beginning of the year, but it has to be returned with your summer phosphorus and chlorophyll samples. The benefit of it is we do the maintenance and get it back to you. One of the downsides is it's a popular parameter. We have 44 meters this year. So you might have to share with a nearby lake. But the benefit is you don't have to take care of that meter and you don't have to purchase one. Purchasing a meter is a possibility. We just ask you to get in touch with us because we're going to ask you to buy a specific one, a specific type, so that we can keep the data consistent across time and across all of our lakes. Meters right now are running around $1,500 to $2,000. Like I said, we'll distribute the meters in time for your first sampling event, which is usually around mid-May. And then you will measure dissolved oxygen and temperature twice a month from May through September. These are the 2 meters that are likely being used as part of our program. The one on the right is a YSI Pro 20, which is the one we currently use and is the one we would ask you to buy if you wanted to purchase one. The one on the left is an older model. It's a YSI 550A. They're a little more finicky for use, but if you've already purchased the meter and you've been part of the program for years and your meter is still working and calibrates, you can still use it. Just know that it's no longer sold and that parts might not be available in the future. So the ones that we give out are all Pro 20s because we've replaced all of our 550As. Here's what the dissolved oxygen and temperature probe looks like for both the 550A and the Pro 20. They're very similar. You can see a yellow cap. That is where the dissolved oxygen probe is, and the cap is a membrane that goes on top and needs to be changed every year. If you have your own meter, you should be changing this membrane at least once a year. And also, if your meter is not calibrating, this is the first thing to check. This is a metal cage, or the older ones have a plastic cage that goes over the top to protect that membrane. And then there's a plastic cap that has a sponge in it, and that sponge is important. We want to keep it moist, not standing water. It just really just needs a few drops to keep moist so that this membrane stays moist and keeps calibrating for you. This is another view of the probe, and right here, this little silver thing along the side, that's the temperature probe, and then the rest of it is the oxygen probe. This is an example of a kit that you will get when you use one of the meters that we have. You have a handheld meter which has a power button that looks like a little sunshine or a little star. And then there's a calibrate button. Those are the 2 buttons that you need to be most familiar with. When it comes to you, the settings will be how they what is needed. It'll be in milligrams per liter and degrees Celsius. You also get some informational things in there. Just one reminding you that it's EGLE's property and you need to return it with your summer phosphorus samples. This is a quick start guide, so to kind of remind you of the different steps when you're going out to take a reading. And then you'll have a cable that's been marked with depths that you need to use for your data sheet. And then it'll come with an extra DO, dissolved oxygen membrane, but you very rarely will need to use this extra membrane. Like I said, we have about 44 meters, and every year maybe one or two have empty boxes where the new membrane was needed. New for last year, and we got them all back, was some new weights that just screw onto the bottom of your metal cage that protects the membrane. The purpose of this is to give it a little more weight. So if it's a little breezy, which it tends to be, you have a little more weight to make sure your cable goes straight down and not to the side. So be careful with these little weights. Um, they are $35, so we don't want to lose them, but you can leave it on there if you can put it away safely. This is just a close-up of what those membranes look like. If you can't calibrate your meter, which we'll go over in a minute, you can try to replace your membrane. And we do have videos on how to do this. And there's some solution that needs to go into these caps before you put it onto the probe. Okay, so now we're going to get into sampling, and prepping for your sampling is just as important as the sampling itself. First, you want to make sure you have calm and dry weather conditions. If it's windy, you're just going to have a harder time in keeping that probe going down straight, even with an anchor. Make sure you have your safety equipment and a friend to help with data recording. This parameter really is best done with two people. One person's doing the measurements and unwinding and winding the cord, and the other is taking the data down. Make sure you check your quick reference procedure checklist that's in your kit. Make sure you have your data forms, which we also provide. And then make sure you turn on your meter for 5 to 10 minutes or 15 minutes if you have a 550A. It needs to warm up and kind of the settings need to settle before you try to calibrate, or you won't be successful in your calibration. So to calibrate your meter, as I said, you need to do this every time you go out. Videos are available on our website at MiCorps.net. Remember to turn on your meter and warm it up a bit prior to calibrating. And then there's the card inside your tubs for as a reminder. And just again, make sure you calibrate every time you sample. Last year when I got some back, there's always a couple that don't calibrate for me, and it makes me wonder how long they haven't been calibrating. So please calibrate every time you sample. This is an example of the first page of your data sheet. When you go out to do your sampling, you're going to put all the normal information at the top, like lake name, county, township, your field sampling number needs to go on there. Mark your location of where you are at on the map. Put your latitude and longitude down. And then one important aspect that sometimes is left blank is to make sure you note what your sampling depth is. It's really important to know what your sampling depth is because you are going to be sampling the water column from starting at 1 foot all the way down to just 2 or 3 feet above the bottom. And if you don't know the actual depth, then you risk the meter probe going into the sediments at the bottom of the lake. And I have been out with people and they're like, oh, I know it's 35 feet here. I've measured it before. And I have on a couple occasions gone where I take a measurement and it's not what they thought it was. There's a couple ways you can measure depth. You can use a fish finder, which I am from a fishing family, so I thought everybody had fish finders, but they don't necessarily. And if you don't, you can do something as simple as maybe using your Secchi disc and lowering it to the bottom because it's a little bit heavy and it has the measurements on the rope. Or you could also I've seen them on Amazon where they're handheld, um, like sonar um, meters where you can like you just dip it into the water and it uses sonar to bounce off the bottom and make a measurement of how deep it is. So those are a couple of suggestions for that. So now we will watch the new video that we created so you can see how the dissolved oxygen temperature monitoring works, and then we'll go over some key points from the video.
Hello, my name is Tamara Lipsey, and I'm an aquatic biologist with the Michigan Department of Environment, Great Lakes, and Energy. Today we're going to demonstrate how to use a YSI Pro 20 meter to measure dissolved oxygen and temperature in lakes using the MiCorps Cooperative Lakes Monitoring Program procedures. Before heading out, please make sure you assemble the necessary equipment, including your data sheet, and fill out the data sheet, including the map of the lake at the bottom.
You will need your dissolved oxygen temperature meter, safety equipment, data sheet and clipboard, pencil or permanent ink pen, and an anchor.
Once you have your equipment assembled, proceed to your monitoring location, which should be located at the deepest point of your lake.
You will need to drop an anchor before you get to your sampling location and drift in. The boat needs to be still for a long period of time to get an accurate temperature and dissolved oxygen profile. Be sure to turn on your meter for 5 to 10 minutes to warm up and to calibrate your meter. Details regarding calibration can be found in our YSI Pro 20 calibration video. After calibration, remove the cap from the probe. Do not remove the metal cage. Measurements of temperature and dissolved oxygen will be taken throughout the water column from top to bottom. Follow your dissolved oxygen data sheet for specific depths. To begin, take a measurement 1 foot below the surface of the water. This depth will be marked on the cable of the dissolved oxygen temperature meter. It will take a few moments for the readings to stabilize, especially the dissolved oxygen. Once readings stabilize, record the temperature in degrees Celsius and the dissolved oxygen in milligrams per liter. Continue taking measurements at the depths noted on the datasheet until you reach a depth that is 1 foot above the bottom depth of your lake. Record this last reading. Carefully pull up your meter, make sure the probe is clean, and replace the protective cap. Turn off your meter, and there you have it, a temperature and dissolved oxygen profile.
To learn more about the MiCorps Cooperative Lakes Monitoring Program, visit us at micorps.net.
Okay, so some things I want to reiterate from the video. The first one is you must anchor just upwind of the deep basin and then drift back over that deepest spot. Most of you are doing this with other parameters, but I know some people, if they're just grabbing a phosphorus sample and it's a calm day, they might not necessarily use a anchor, and some people don't even have heavy duty anchors. If you are interested in doing this parameter, you have to have an anchor that's going to keep you very still, even on slightly breezy days. You're going to be, especially if you have a deep lake, you're going to be in that spot for a longer period of time than just grabbing a phosphorus sample. So this is a must-have. Again, check for your actual basin depth, as I noted earlier. Make sure you turn on your meter and calibrate it if you did not do that on shore. Take that cap off. Sometimes people just forget that the cap needs to come off. There's the actual probe is in that cap. The purpose of the cap is just to protect it. So make sure you take off that cap, but leave on that metal guard. That metal guard protects that membrane, and the membrane will get damaged if you tried to sample without the guard. And then you can add that little weight if needed to make sure you're keeping your cable straight. One thing I didn't mention before is the handheld meter the cable does need to be attached to it first before you can calibrate it. But I want you to, after you're done using the meter, take the cable off of the meter before you put it away. And this just helps with crimping the cord, which I'll talk about a little bit more in a second. So when you're taking a measurement, you're going to, everyone, no matter what the depth of your lake, is going to start at 1 feet in depth. And we have marked your cable with electrical tape. If you're getting your own meter, you can do the same. Just buy some electrical tape that is lighter in color so that you can read the depths that you write on there. Make sure you have not changed the settings on your meter and it's measuring in milligrams per liter. There is a middle measurement, that's the percent oxygen, but we are measuring in milligrams per liter, not percent oxygen. And then you're going to move the probe with that slight jigging motion that was shown in the video. And this is important. The way the probe works is that it has to have flowing water over the probe. The probe is measuring dissolved oxygen right around it, and it in that process uses up the dissolved oxygen a little bit. So you have to make sure you're constantly moving the probe so that it's getting fresh water and measuring that dissolved oxygen number. You will wait until the readings quit drifting, and I'd say to the nearest 0.5 milligrams per liter. And so what I mean on that is when you're measuring dissolved oxygen and you're changing depths, it's going to take a few minutes for it to stabilize. So it might say 11.6 milligrams per liter, 11.2, 10.9, 10.5, 9.2, 8.4, 8.9, 9.0. So once it starts to get where the tenths number is just changing by 1 or 2, that's when you take that measurement. You don't have to wait for it to absolutely stop, but as long as you're within 0.5, that'll be fine. And then once you get that reading, you go to the next depth on your data sheet and you stop about 2 to 3 feet above the sediment to make sure you're protecting the probe. If you have a shallow lake, you might do additional depths at the shallower numbers. So let me see if the next, no, let me, oh shoot. Well, the data sheets are marked at 1 foot and then 5 feet and then 7.5 feet and then 10 feet and then 12.5, so on. If you only have a 12-foot deep lake, you might want to mark more often the results that you get. So maybe 1 foot and then 2 feet and then 3 feet, whatever you decide, just so that you can get that stratification process in your shallow lake. Although shallow lakes will not stratify as much as deeper lakes. Okay, so I want to talk a little about after sampling. You want to turn off your meter, disconnect that meter from the cable, and then wrap up that cable carefully and put it back into your case. Some of the cases, most of the cases look like this. They're heavy duty. A few of them are still more Rubbermaid type cases. Um, Crimping the cable, the meter itself is a delicate item, but the cable is even more delicate, and they really it's just like any like your charging cables. I don't know about all of you, but I go through a lot of charging cables, and I think it's because they get bent and then they no longer work. And the same goes with your cable for your meter. We have to make sure we're not bending that cable. Make sure your meter is completely dry before you close the case. This includes the cable, so that might take some time, or it will cause mold. I have had a couple, especially with these heavy duty cases, come back and I open them in the fall, and they are full of mold because it was wet when it was put away. Store the meter in a dry location out of the sun. And when you're drying it out, same thing. Make sure you maybe have it in your garage and open so it can dry out. Make sure you keep your sponge damp, but don't store it in standing water. If you store it in standing water, algae will grow over time and it'll get kind of slimy. And in the past, other types of weights, some types of lead fishing weights where you attach the cables, but we don't want to do that any longer. That's why we bought these nice um, weights that are specifically made for the meters so that we don't damage them. Okay, and one of the data sheets that you'll get is a graph that looks like this, where you can mark your dissolved oxygen and temperature, but we also have some Excel tools that you can use to develop these graphs on our website. Just a reminder to enter your data into the data exchange by October 31st and make sure you send us a copy of the results. Don't forget to return your meter with your last water chemistry sample drop off. So that's going to be for most of you, your phosphorus. Some of you will be doing your chlorophyll and phosphorus, turning them in. Usually the end of August for the UP and then September for most of Michigan. If you forget, you need to contact me and make a plan for either one of the volunteers to ship the meter at your cost or bring it to Lansing for me. Make sure when you turn in your meter, you include the sponge, but no standing water. I got at least a half dozen meters back last year that didn't have a sponge. And I don't know if the sponges were just dirty and people didn't want to, they need to be replaced, but just leave it in there. I'll put in a new sponge. It just gives me reassurance that it had a sponge in there throughout the sampling season. And then just another reminder to disconnect your meter from the cable. And with that, I am finished and we have some time for questions.
Thanks, Tamara. That was great. I really like how we are able to kind of work in some of those videos into the training. It's kind of livens things up a little bit.
Yeah, I agree. Blah, blah, blah. Tamara.
Oh, I think it works for all of us. It's great to be able to visually see the process of monitoring is particularly nice. We do have a few questions,
Okay.
and we'll start with a couple that have to do with the actual, process of collecting the data when you're out on the boat.
Yep.
Martha asks, how much time will we need to leave the probe at one depth to stabilize that reading at plus or minus a half a milligram per liter?
I mean, it's less than 5 minutes. You're not out there for like a half hour each depth, but it does take some time in some lakes. Just for it to settle down. It gets easier the deeper you go. So sometimes when you're getting deep, it's only, 20, 30 seconds. But in the beginning, it might be a minute or two before it settles down and you can record a reading.
Similar question, kind of a good follow-up. Will there be fluctuations of the readings at all the depths, and maybe you started to touch on this, or after it settles at 1 foot, you can move through all the other depths without waiting?
No, you'll have to wait at each depth because you're changing the environment that that probe is in. So it gets used to the 1 foot, but then you're putting it down to 5 feet, and the it's going to be different based on what I showed you with those graphs. The temperature is changing, the dissolved oxygen is changing. So, I mean, um, the technology has really improved. It takes less time with these Pro 20s than it did the 550, but you're still going to have to wait anywhere from 30 seconds to a couple of minutes at each depth.
Thanks. That helps us make sense and also helps us think about how long it's going to take, the actual
Yes,
monitoring
exactly.
process.
Yep,
Yeah.
that's why we need the anchor because it does take some time, especially if you have a very deep lake.
All right, we have a couple questions about meters themselves. There was one lake association who said a few years ago they bought a meter. It's not a YSI Pro 20. Can they still use it?
Unfortunately, no, we are only using the YSI Pro 20s unless you've been part of the program with your 550A and it's still working and calibrates.
Right, because all those meters work a little differently. They have,
Right.
they use different technology, which can affect the readings. And of course, we want to be able to answer questions and troubleshoot if there are any issues with the meter.
Yeah, my understanding is when we switched from the 550A to the Pro 20, there was a lot of discussion and looking at, talking with the manufacturers and making sure that the data was going to be similar in quality so that we could have those long-term data sets.
Yep, absolutely. Regarding potentially sharing meters, someone asked if multiple lakes are sharing equipment, does that affect the accuracy? For example, does the membrane or other parts wear out or get clogged up if it's used multiple times each season?
Um, I think more use does impact, but at most you're going to be sharing probably with one other lake. And these meters are built to, I mean, they every time they send me a new pack of membranes, they send me 6 of them. So if you were using these every day, then my assumption is you would have to change the membrane more often. But even with 2 lakes, I think you're going to be using them so infrequently that the worst that could happen was like a membrane might need to be replaced, but it's fairly simple. And again, every year, even with people sharing, I only get maybe 1 to 2 meters that have had to replace the membrane.
Mhm. Yeah, that's helpful to know. Another question just came in. Can you do Secchi disc reading at the same time that you do your dissolved oxygen test? Or is it better to do this test before you do a Secchi reading?
We always do them separate. I mean, there really isn't a reason to do both at the same time. I guess the person who's doing the Secchi is on the shady side of the boat and somebody else wants to get started on the dissolved oxygen on the other side of the boat, that's fine. That's not a problem. Just don't want to do dissolved oxygen right in the same spot you're doing the Secchi because the motion from the Secchi might move things around, and affect your dissolved oxygen reading.
Yeah, thank you. I mean, you could definitely like on the same trip out onto the lake,
Oh,
certainly.
for sure.
Yeah,
Yes.
take those samples, but yeah, you don't necessarily want your disc and your probe, bumping into each other in the water at the same time.
Right. Yeah. But
Yeah,
for sure, yeah, if Seki has to be taken every other week as well. So yeah, you could go out on the same day and collect both. Yep. Mm.
great. All right, I'll just remind people if you have any questions about dissolved oxygen and temperature, or honestly anything else about the
Yeah.
CLMP,
Mm.
we have a little bit of extra time. We're scheduled for a lunch break from noon to 1, which we'll probably close this Zoom right down and then open it back up right before noon, where people or right before 1 o'clock at the end of the lunch hour, where people can join back up if they want to. But here's your chance. The team's all here. If you have any other questions you want to ask, there, Eric just popped up. If you have have any other questions for us in the next few minutes, that's what the chat box is for. We're here to address those, and we'll stay until the questions disappear. And then if we're out of questions, then we'll close down for our lunch break.
Can people also unmute themselves at this point and ask questions if they
Yes,
want?
yes, you can. If you have a question that you're concerned it's going to take you a long time to type it in, and you'd rather just turn your microphone on and ask us, feel free to do that now too. We can do a Q&A free for all for the next few minutes. I did have one conversation, if people are thinking about questions, I had one conversation on the side with somebody about the enrollment deadlines and signing up for different things. And in particular for dissolved oxygen, the deadline for this is actually passed. If you have not already enrolled in dissolved oxygen, it's unlikely we'd be able to squeeze you in. In fact, if you go to the enrollment website right now, you will not even see dissolved oxygen as an option for you. So if this is something that's interesting to you and you're not already signed up, the best option for you would be to consider it for next year, when we can make sure that we can have enough equipment to get you set up with a meter and so forth. So besides that, there's still several parameters that are still open, either with deadlines of May 10th or a couple of them, which we'll talk about this afternoon, Score the Shore and Exotic Aquatic Plant Watch. You have until August 31st to sign up. So even if you've already enrolled and then you sit in on the training, say for Score the Shore, and think, this is really cool, I want to do this, you could add Score the Shore anytime this summer. Or if you only want to do Score the Shore or Exotic Plant Watch, you have plenty of time to enroll yet this summer. All right, I am not seeing any more questions. Eric did just put a nice link to the enrollment information, including all those deadlines I was referring to. So that's in the chat if you want to refer to them. But again, maybe we'll stick around for a few more seconds to see if any more questions come in or if anyone unmutes with a question.
And I'll just say, just feel free to email me or give me a call if you're thinking about purchasing a meter. I can send you direct links on where to get them and what we buy so that there's no question. There's a couple different types of membranes and probes, so it can get a little confusing. So just feel free to reach out to me and I can let you know what to purchase.